video, we are going to talk about the quantum mechanical atom. But before that, we are going to talk about the history of atom. If we are going to talk about atom, we have to go to the ancient Greece 400 BC, and there was a brilliant philosopher named Democritus. He proposed the word atomus, which means uncountable. While Erwin Schrödinger, he proposed the quantum mechanical model of the atom, which treats electrons as matter waves. Atoms are the basic particles of a chemical element. Protons is a positively charged particle together with the electrically neutral particles called neutrons, which makes up the nucleus of an atom. Electron is a negatively charged subatomic particle that can be either bound on atom or free. Next is neutron. It is a subatomic particle that has no electric charge and a mass greater than that of a proton. Lastly, the atomic nuclei. It consists the electrically positive protons and the electrically neutral neutrons.
The wave mechanical mode is one of the popular theory which proposes that electrons are almost as much like a wave of energy as they are light particles. They're moving so fast that they're not really in one places at any given time, and they keep changing their path in response to the field around them. The wave mechanical model arose as a refinement of the Bohr model, which was limited by hydrogen. A new model would come from the concept that all forms in the electromagnetic radiation exhibit the properties of waves and particles. This concept from French de Broglie. This particulate might also exhibit wave characteristics, although these waves would not be obvious at the scale of day-to-day observation. Even at the bathtub, we can see two waves interact to produce a large wave, then pass right through each other without injuring each other.
Ground state is defined as the lowest energy state of an atom's molecules or ions. In other words, the ground state represents the most stable configuration. This means feel inertial before moving to the next shell, and when exposed to energy, electrons can jump to a higher energy level that is called excited state. Excited state means that one or more electrons was bumped up to a higher level so that the lower level weren't completely fell up before you had it. Example, when the electron is steady in the one plate, so that is means the ground state, but if the electrons is jump up to another plate, so that is called a excited state.
What is electron affinity? Electron affinity is the amount of energy released or absorbed when an electron is added to a neutral atom in the gaseous phase, forming a negative ion. It is usually measured in kilojoules per mole. Positive electron affinity. When an atom has a positive electron affinity, it means that the atom releases energy when it gains an electron. Atoms with high electron affinities are eager to accept electrons. This makes them more likely to form negative ions. Example of positive electron affinity is elements like chlorine and fluorine. Have a high electron affinities. They readily gain electrons to achieve a stable electron configuration, often releasing energy in the process. When an atom has a negative electron affinity, it means that the atom absorbs energy when it gains an electron. Atoms with low negative electron affinities are not eager to accept electrons. This makes them less likely to form negative ions. Example, elements like neon and argon have low electron affinities. They prefer to remain neutral rather than gain electrons, so they absorb energy if they do gain an electron. Why electron affinity important? Because of chemical reaction. Chemical reaction understanding electron affinity helps predict how atoms will interact in chemical reaction, especially in forming bonds. Second is ion formation. It explains why some atoms form ions more readily than others. Third is stability. Atoms with high electron affinities tend to be more stable when they gain electrons, leading to the formation of more stable negative ions.
That's all, everyone. We hope that you learned something from us. Thank you for watching.